Hello, this is Haley, H3 platform. Here we will show you our CXL memory pooling solution. Later we will demonstrate our API, application programming interface, and our GUI, graphical user interface. This is the system architecture of memory pooling. The CXL switch and the memory modules are in two separate chassis. The CXL switch chassis, compute node, and the memory chassis are connected by CDFP cables. The CXL Fabric box is with 16 CDFP connectors, and each connector is PCIe Gen 5 by 16. The memory module chassis is with 16 double wide, full length, and full height slots. This memory chassis is also with 16 CDFP connectors to be connected to Fabric box. The compute node will go through the Fabric box to the memory chassis to access the CXL memory module. As for the system components, they are the Fabric chassis, CDFP cable, and the memory chassis. As you can see, the Fabric box is with the XCON CXL switch in it. There are 8 CDFP connectors in a row, so there are totally 16 CDFP connectors in 2 rows. The CDFP cable is up to 1 meter. The memory chassis is similar to GPU expansion chassis. Each slot is connected to 1 CDFP connector. Let's talk about the principle of private CXL memory mapping. The memory pooling is through the memory address mapping. The H3M CPU will get out the memory module as its own memory and create the global memory address. When the compute node boots up, the NCPU will request a block of the memory size from the host memory. For example, request 1 terabyte memory size from 1 terabyte offset. Then the NCPU will map a memory descriptor from a memory module, for example, the 16 gigabytes of the memory module, to the host memory address. Finally, the 16 gigabyte CXL memory will be added to the compute node. What about the CXL memory sharing? One single memory descriptor can be mapped to 2 different hosts. 2 hosts can share the same physical memory. Please note that the NCPU does not control the memory write protection nor the memory cache coherence. The NCPU will only provide the sharing capability. H3 provides a complete API list for orchestration integration. It's easy for data centers to manage the CXL memory pooling by using API. Here shows an API example. This example is to get the memory property of all memory module. You may pause to have a close look. In the next part, I will demonstrate how to operate CXL memory pooling by application programming interface and the graphical user interface. Here I will demonstrate the API part first. Let's get the host list first. After putting on the CXL host, you will get the host list. Currently, there are 4 host ports. They are named from host 1 to host 4. Their entries are counted from 0 to 3. They are the actual slots on the chassis. So there will be 4 upstream ports. Now let's get the device list. Please put down the CXL devices. Following the command, there will be entries counted from 4 to 15. And the number of downstream ports gonna be 12 in total. The memory modules in use are Samsung CXL Memory Expander 2.0. Their capacity can be up to 512 gigabytes. can support 32 memory descriptors. Now we are going to create a memory descriptor. We're going to give a post command on the AMD on device 5. Let's create a memory descriptor with 16 GB and make it private. After that, you will get a new memory descriptor, AMD1, with 16 GB. Now let's get back to see the AMD list of device 5. This is the memory descriptor 1 we have just created. It belongs to device 5 with 16 GB. Here the shared memory shows false, which means private. You can see that it hasn't been mapped to any host port. Then let's create another 4 GB of memory descriptor. 4 GB. Now it's up there. Let's get back to the AMD list of device 5 to check it out again. Now there are two ones, AMD1 and AMD2. Now I'm going to create the third one. Let's create a 492 GB. This time I want to give it true to share the memory. Okay, let's get back to the AMD list to check it out. Now there are 3 memory descriptors got created. They are separately 16, 4, and 492. Private, private, and shared. Now I want to show you how to delete memory descriptor number 2, which is under device 5. Let's give it a method command, delete. Okay, let's get back to check it out. AMD2 has gone. Now only 2 are still here, 16 and 492. Now we are going to display how to assign an AMD to a host port. Let's give a patch command on memory descriptor 1 first. We want to allocate memory descriptor 1 to host 1. Here I give it a command, a patch. Okay, here I have successfully assigned memory descriptor 1 to host 1. Let's get back to the AMD list of device 5 to check it out. You can see that this AMD has already been assigned to host 1. You can also see the same result on the list of host 1. AMD1 has been assigned to host 1. This is host 1. Okay, now I want to attach AMD3 to host 4. Give it a patch command as well. Let's come back for a quick look. It was 3 that is patched to host 4. So we can see host 4 at this place. Let's check it out on the host list. You can see that AMD3 has attached to host 4 already. Thank you for your watching. Next video will be the CXL GUI demonstration. Okay, let's get started with our demo. Here you'll learn how to configure the resources and see the result on the overview page. This is the host list on the resource page. There are hosts from entry 0 to entry 3. So there are 4 upstream ports. As for devices, they are from entry 4 to entry 15. So there are 12 downstream ports. The memory modules in use are Samsung CXL Memory Expander 2.0. Your capacity can be up to 512 GB, can support 32 memory descriptors. Now I'm going to create a memory descriptor. I will create 3 MDs. MD1 will get 16 GB private. MD2 will get 4 GB private 2. MD3 will get 492 GB. This time I'll give it a shared. Then you can see the 3 memory descriptors on the list. Next, I want to show you how to delete a memory descriptor. Here, select the Delete tab. This time I want to delete number 2. Look, the memory descriptor 2 has been successfully deleted. Then I want to show you how to attach memory descriptor to host. Let's get back to the host page. I'm going to attach memory descriptor 1 to host 1. The first step is to select host 1 and then memory descriptor 1. Then hit the Attach tab. Now the memory descriptor 1 and host 1 have been mapped successfully. Then I want to select host 4. I want to map it to memory descriptor 3 by hitting Attach. Now memory descriptor 3 and host 4 are also successfully connected. Let's go to the overview page to check out the results. Here's the overview of all the hosts and devices. You can see the available and attached capacity of the device on the entry 4 clearly. Okay, thank you for your watching.